Yeah, there we go. All right, rejection region and critical values. Shh, stop. So, oh, what a nice class, healthy 11th graders, isn't it? Oh. Okay, anyways, rejection regions and critical values. This is going to be your step 4. Okay, so the step 4. So the step 4 we already have is a p-value. This is another alternative method to test for step 4. So the rejection region, the critical region, it's the range of values for which the null hypothesis is not probable. If the test statistics fall in this region, the null hypothesis is rejected. A critical value z sub 0 separates the rejection region from the non-rejection region. So this here, this, I don't know if I can, no, okay. So this here, that is our z critical value that we find, that we look up in step 2. Okay? So our guidelines for this, oh, green. So specify the level of significance, which we do. Decide whether the test is left, right, or two-tailed, we do. Find the critical values in the hypothesis test. Yes, this is all stuff we've already done. Left-tailed, find the z-score that corresponds. Right-tailed, find the z-score that corresponds to an area. See, this is cumulative area right here. Okay? That's how you find the cumulative area. Okay? Some people are using the level of significance, getting the negative value. It's a right-tailed test. You just make it positive. Not a big deal. Two-tailed test, remember, half, right? Break it in 2. Sketch the standard normal distribution. Draw a vertical line at each critical value. Shade the rejection regions. This is all step 2. We do all this already. Okay? Now, find the critical value and rejection region for a left-tailed test at a level of significance of 0.10. So here we are. This is what we have already done. So here's your point right here, 1, 0, 0, 0. You look it up in the back of the book. You get a z critical value right here. My z critical value of negative 1.28. That's your critical z value. Here's the line that separates the rejection region from the non-rejection region. Okay? So if your z is less than negative 1.28, you reject the null hypothesis. So if your z test statistic, okay, and where does that come from? From step 3, right? You put it into the formula. So the z test statistic from step 3 is this part right here. You then find where it's located. So you have this critical value. So if it falls in here in the rejection region, okay, or if it does not fall in the rejection region, that's what is meant by the rejection region. And I'll show you where it is in your notes, the verification of it. Find the critical values and rejection region for a two-tailed test with a level of significance of 0.08. We've already spent time doing this. We've already done a step 2 numerous times. So it's a two-tailed test. We know that. Okay, how do you know? It tells you right here. Okay, two-tailed test. So you have to break it into 0.0400. Look up 0.0400, and that's where you get the z equals negative 1.75. And then the other one, remember they said the 1 minus. So if you do 1 minus 0.0400, that gives you a cumulative area of 0.9600. So you either look up the 0.0400, you get the negative 1.75. Okay, you know it's the same amount here. Okay, it's symmetric, okay, on the 0. Okay, so you know it has to be positive 1.75. If you forget that, you don't know that, then you look up 0.9600, and that will give you 1.75. So two things can happen. There's 2 rejection regions. There's 2 critical z values. So you reject the null hypothesis if your z is greater than 1.75 or if your z is less than negative 1.75 because it falls in the rejection regions. Okay? Come on. So using the rejection regions for a z-test. So use the rejection region, conduct the hypothesis test, calculate the standardized test statistic. Step 3, if the standardized test statistic, okay, here is what I was talking about. So if your step 3 is in the rejection region, then reject the null hypothesis. If it is not in the rejection region, then fail to reject the null hypothesis. Okay? This is all right here, your step 4 into 5. So that's a new step 4. So I might say using the p-value test, I might say using the rejection region, determine whether you reject or fail to reject. Normally what happens is in 7.2, which is the first one we did, we use the p-value. In 7.3, we use rejection region because the p-value is a little weird when you're doing a t-test. And then in the third one, so that's 2, 3, 7, 5, 7.4. Okay? In 7.4, you choose. Okay, that's usually how I've done it in the past. All right, 7.2 is the p-value, 7.3 is the rejection region, 7.4 you choose. Okay? So using the rejection region, it's really the same thing. All right, state the claim mathematically and verbally. So, you know, your claim, remember you have to tell me what is it? Is it the mu? Is it a p? Then you identify the null and alternate hypothesis. Remember, that's all your step 1. Specify the level of significance. Okay, it's given to you. But I don't have this all. Specify the level of significance. Sketch the sampling distribution. Determine the critical values. So this is your z or t, and I'll put a little c here. Your z critical or t critical values. And that's just in the back of the book. I had blue sheet because they used to have blue sheets. We would copy and make copies, but I said, I'm not going to keep making copies. We'll just use the back of the book because we'll lose them. Determine the rejection regions. So you got to shade the tails. Remember, put a note down. Always shade away from the center. Okay, it's the tails. So if you are drawing your bell curve, where are the tails? Okay, here and here. Okay, so you shade the tails. And then find the standardized test statistic. That's your step 3. And then make a decision to reject or fail to reject the null hypothesis. Okay, this is where it gets a little weird. You're not finding a p-value, and you're not comparing it to the level of significance. So here, you tell me, does it fall or does it not fall within the critical region? That's what you tell me. Does it fall within the critical region or does it not fall within the critical region? Okay? And then interpret the decision in the context of the original claim. That's your box sheet. Okay, I call it the box sheet. Remember, step 5. What is your claim? Remember, it gives you your claim. Is your claim the null hypothesis or the alternate hypothesis? Do we reject or fail to reject? There is enough evidence to support. There's not enough evidence to support. All that, that's your box sheet. Okay? Does that make sense? So there's only 2 problems that I want you to practice with this. And so on page 392, 393, 39, and 43. And I will help you with the step 4 when you get there. Otherwise, it's exactly the same what you've already been doing. Okay?